For worksheet 2, I had question number 2, which was let G be a group and let H equal the set of the inverse of X such that X is an element of G, and I had to show that G equals H. So in order to show that G equals to H, I used if G was a subset of H and H is a subset of G, then G equals H. So the first thing that I want to talk about is that G is a group. And the 4 properties that makes G a group is that it's closed, has an identity, and has inverses, or an inverse I should say, and is associative. So the most important part for this question is the fact that it has inverses, because of course they say H is the set of inverses. So the first thing is if we let H be the subset, the set of inverses such that X is an element of G, therefore the inverse of X, of course, is an element of H. But since G is a group, we know that X inverse is also an element of G. So, of course, if they share elements, that means that H is a subset of G. Now, so we proved one way, so now we have to prove the other way. The other way, we can start with saying let X be an element of G. Then, since it's a group, we know that the inverse of X is also an element of G. So, if we take the inverse of X and then apply the inverse, that will equal an element of X. So, since X is an element of G, and we applied the rule of H, that means that this is also an H. So that must mean X is an element of G and X is an element of H, meaning that G must be a subset of H. So since H is a subset of G and G is a subset of H, we can say G equals H.